Okay, so today we're doing the transition metal coupling of two different coupling partners. So in this particular lab, you're going to start with some boronic acid, which usually is represented with this boron atom and two hydroxy groups right here connected to your arrow. The other coupling partner in this sort of scheme is the arrow bromide. And what you add to put these two molecules together into this bi-arrow, so you have to add some palladium zero. Now these reactions, they look kind of complex and a little bit confusing because there's all these different catalysts, but really it's not so bad as what you might think normally, because all you're really doing is you have this metal carbon bond, which is a nucleophile, or you can just sort of think of it as a negative charge. You're just adding it to this bromide, which you can sort of think as the electrophile of the positive charge. So you're still doing the same thing. You're just making a bond between a negative and a positive charge to get your product. And today we're doing the Suzuki. The Suzuki uses the boronic acid. There's also a bunch of other different types of cross-coupling reactions that have some metal here. So you can have, this metal as a zinc, or you can have it as a tin. It just today we're doing the one with boron. Okay. So in this first step, right now what we have is this parabromoacetophenone in this flask, which is this compound. That's already preloaded and ready to go in this flask here. Now we're just going to add 10 mils of ethanol to it. And it should slowly sort of go in pretty well. Now we're going to have it start to stir, and we have to now add the next coupling partner to the mixture. So the next coupling partner is this is now your boronic acid in this little vial. So now what we're adding to the reaction is this boronic acid. So this is now the second component of this reaction right here. And I'm just going to pop it right on into the flask. And we're going to start to stir it now. Should be all mixing and ready to go. And now at this point here, we're going to start by adding this palladium absorption, or this palladium chloride solution. It's this yellow mixture. We use this pipette man right here, which lets us perfectly dispense 200 microliters into the reaction. And sort of weighed out in this pipette tip right there, pretty nicely. Now we just add it into the reaction. You can zoom in. So now at this point here, it looks sort of orange from adding this solution in there. And the last thing that we add before letting it mix is this 1 molar sodium hydroxide. We just add about 2 mils into there. Yeah, we just add 2 mils into the reaction now. And so here, take a note of the color, because I think the color change over time will change a little bit at least. And it sort of became just a little bit milky. So it seems like our reaction might have started now. And at this point, we're just going to wait for 20 minutes or so. So we've come back 20 minutes now, and you can see that our reaction is a little bit more dark. You can see this sort of black metallic stuff in here. So what we're going to do is we're going to add a little bit of water, around 5 mils into it. We're going to let it sit for a minute. So what that dark color was what you're seeing is this sort of this palladium chloride, know, is sort of turning into this palladium zero, which is this black metal. It's not a shiny metal, but it's more like black. Now we just are going to let it sit for maybe another minute. It looks a little bit like it's kind of milky inside of here. Maybe we can cool it a little before filtering it. Yeah, now it looks like there's some white solid coming out of it. So it's turning solid out of the solution. So then at this point is we gotta filter our product through a little tiny funnel. So we're gonna go over to this little small Hirsch funnel, which has a little filter paper in there. And it's just mostly useful for isolating a little bit of the product. And so we're going to do our filtration now. So we have everything set up. And in the first step, you have to get the filter paper a little bit wet before you can add your product on the top. So now we just filtered our product. So then, once the filtration is done, we're just going to do another little rinse to rinse off anything water soluble that we don't really want. Okay, so now at this point, you know, most of the stuff from the first sort of filtration has gone through. We're just going to now wash it with just a little bit more cold water. Okay, so we've waited now a few minutes drying our organic, been sucking the water out of our product. And so what we're left with is now our product inside of this little filter. And so what we're going to do is we have some DCM here, and we're just going to take this product and dissolve it in a little bit of DCM and just filter it right on through into a different sort of container. Okay, we've now filtered our product into DCM, and in here there's sort of all this palladium left over and a little bit of water. So we've got to get that out. We get that out by using this dry magnesium sulfate, which should absorb the water and all of the metal and leave behind our nice clean product at the end. So we're going to put some of this magnesium sulfate into a pipette. It has a little bit of cotton here to use it as a filter. Here we have this round bottom flask that has a known weight on it, so we can find the weight of our product at the end. And we're just going to slowly sort of transfer our solution into this pipette. We can maybe have it go through a little bit more quickly. So I'll show you this part. So here our pipette now has this little black layer on the tip, which is the metal and all that water that we got out. And we're left with this nice clean solution of our product, we hope. Okay. So we're going to do our last step where we just have to remove the DCM and get the yield and check NMR of our product. Now we're just going to weigh our product and check the NMR.